Howdy folks, welcome back. We're going to be looking at number 56 through 60 on TMSA number 9, 25Q. It asks, what is the area bound between the x-axis, y-axis, and the curve y equals square root of x plus 1? So the idea here is if we try to visualize what this graph looks like, it's a square root function and it's going to be shifted over to the left by 1. So it's going to look something like this. So what we find out is at negative 1, y equals 0, and they want us to get the area between the x-axis and the y-axis. So they just want this area here. So to get the area of a function, it's going to be the integral, and we're going to go from negative 1 to x equals 0. Those are our bounds. And in this case, we don't need to do anything fancy with a function. It's just the square root of x plus 1 dx. Just throw that bad boy into the calculator, and it'll... Have a good one, Lorena. Take care. All right, next one, number 57. A colony of 5,000 ants starts to double in number every 6 days. An aardvark eats 1,000 ants per day. When should the aardvark be released into the colony to stabilize the number of ants at a constant number? So here we happen to have a doubling problem. So for number 57, we first want to try to determine what is the function we're working with. Well, we start out with 5,000 ants. And it's going to double, so we're going to multiply it by 2 every 6 days. So the model for doubling is going to be 2 to the t over the amount it takes to double. So if it doubled in 8 days, we would divide it by 8, okay? And so all of that is going to be the amount of ants after t days. Now here they tell us that an aardvark eats 1,000 ants a day. So what we really want to try to, and they want us to find out when should the aardvark be added so that every day when we get new ants, that 1,000 new ants gets eaten and the population doesn't grow. So we're talking about how quickly something is growing. That's the derivative. So what we're going to want to do is we're going to want to take the derivative of the population with respect to time. And so there's going to be an ln trick here, and so you throw that into your calculator. I'm just going to skip over, and I'm just going to look at what that part is in the solution because I'm being lazy. Oh, well, they just throw it in. Just throw it as a solver, right? So you're going to solve the derivative of 5,000 times 2 to the t over 6 equals 1,000. That's going to give us a time of 4.75 days. So that's when the aardvark is going to be added, because at the 4.75 day, that's when the population increases by 1,000. All right. Let's go ahead and take a look at number 58. Oh man, 58 looks funky. Normally we're thinking, hey, this is a matrix problem, but the brackets are gone. There are these vertical lines, and then they want us to solve for A over B. How do we solve that? These vertical brackets are telling us that we want to get the determinant of the matrix. So in our calculator, we would put in the matrix with these elements in there and then calculate the determinant. The determinant of a matrix with 3A, 12 as its 1, 2 element, 2B as its 2, 1 element, and then as its 2, 2 element, 9. Well, what is the determinant? The determinant ends up doing some funky math, and for a 2 by 2 matrix, what it does is it multiplies these two numbers, and then it subtracts it from the product of these two numbers. So what we're really doing is 3A times 9 minus 2B times 12. That's the determinant, and all of that determinant is going to equal to B. Alrighty. So what you can do in your calculator is have it evaluate the determinant, and then from there you're going to do a solve. You're going to solve for A divided by B. Now there's a couple of ways to do this. You can say solve for A over B, and it should give it to you. If the calculator struggles with that, set B equal to 1 so that you get 3 times A, 9, that's 27A. 2 times 1 times 12, that's minus 24, equals 1. And then from here, when you solve for A over 1 is the same thing as A over B, and there's your answer. Okay, they want us to solve for the amplitude of this function here. We're going to be integrating from several bounds. So what we need to kind of quickly know is when is cosine of x, thankfully there's no funky modifications on the frequency of the graph. So all we need to ask ourselves is when is cosine of x going to be equal to 0? So cosine tells you how much you stick out sideways as you sweep around the circle. And we're going to get 0 at 90 degrees, which is pi over 2 radians. And then 180 degrees later at 270 degrees, or 3 pi over 2 radians. And so it's always going to go up by 2, or it's going to go up by pi. So right here, because x is 0, cosine is going to be 0, or the whole function is going to be 0. But then this guy over here, why isn't it writing? This is going to be pi over 2. This right here is going to be 3 pi over 2. This guy's going to be 5 pi over 2. 7 pi over 2. 9 pi over 2. So the other thing you could do is graph it into your, well, you don't know what a is, right? So what we're doing is we're going to solve. We're solving the integral from 7 pi over 2 to 9 pi over 2 of a times x times cosine of x dx equals 18.5. And then we just solve for a. Alrighty, last one, 60. Ooh, how do we do this? There's a couple ways to do this. One way is the radius of this circle, or arc, is going to be 4.75. This line right here happens to be 45 degrees. Now they want us to get the little radius of this guy here. So let's go ahead and build it up a little bit. 4.74 times cosine of 45 is this distance right here. Okay, now to that, we are going to add r, and that angle is also 45 degrees. And then lastly, from here to here is another radius. So putting it together, r cosine theta plus, let me say that again. 4.74, which would be the radius of this big arc, times cosine of 45, is going to give us how much it sticks out to this part. Then we're going to do the same thing, but with a little r, times cosine of 45. It's going to get us to this point. And then lastly, we're going to add one last bit of little r, and that's going to equal this full length all the way over here, which is 4.74. So what are we getting at? 4.74 times cosine of 45 plus little r times cosine of 45 plus little r. All of that is going to be the full distance across. This is a square, so that's also equal to 4.74. And from here, you can go ahead and start throwing it into your solver, or recognize that cosine of 45 is square root of 2 over 2. So 4.74 times square root of 2 over 2 plus r. I'm going to factor this out. This becomes square root of 2 over 2 for the cosine of 45. And this guy, I'm going to get a 1 equals 4.74. Okay, move things over and solve for it, and that's how you do number 60. Not too bad, but it does look intimidating, because how often have you seen a shape oriented in that way, right?